Okay, so hopefully you all can hear me now. All right, give me just a second here. Sorry, I was having some issues. Okay. All right, we're good. All right, just needed to make sure about that. Sorry about that. Keep having some little issues here and there with my new laptop here. So, all right. So, anyway, what was I saying? Anyway, happy Thanksgiving again. So, anyway, today is part 2 of our introduction to AI agent stream. I don't necessarily want to do a full recap of what we did in the previous stream, just because you can always go back and watch that. But I do want to cover or reset kind of like what we did in the last stream a little bit. That way we can have a context for what we're going to be doing in this stream. So I'm going to go ahead and share my screen. And I'm still freaking out about this stupid microphone. So let me just make sure one more time here that we're good. That, but I do want to cover. Okay, yeah, sorry about that. And I noticed that the audio on the previous stream was also kind of like garbled as well. So let me go ahead and share my screen. And what was I going to recap? Oh yeah, so to recap what we did last time, and let me make this bigger for y'all. Okay, so in the previous stream, what we had covered was essentially the script. Now, this script is a little bit refactored from the last stream, but it's the same. It's the same contents more or less. I did add one tool in here. Basically, what we covered in last stream was a high-level introduction to what an AI agent is, and then we ended the stream by coding 3 variants of agents. We specifically using the Strands agentic framework here. So what this is doing here, so just to kind of recover what this script is doing. So we instantiate our model. So we're leveraging the OpenAI models here using you can see that we're using GPT-5 Nano here. And you can see that, hold on. Sorry, I think somebody just was making a comment. Okay. No, it wasn't you. It wasn't you. It was me. That was my fault. Sorry about the audio issue hiccup there. So anyway, so yeah, we set up the model, and then with Strands specifically, the way that you create tool integrations, and there's multiple ways to do tool integrations, but the simplest way in my mind is simply by creating a standard Python function, and within the standard Python function, so you have the code naturally that you want the agent to be able to make use of, and we simply decorate it with this tool decorator here. So just to remind you, we are importing this from up here. This might be still a little bit small for you, so let me make that even bigger. Okay, so we made that bigger. And now the one thing to keep in mind here is that whenever we are passing tools into Strands or even other agentic frameworks, is like we have this doc string here, and typically speaking in Python, we do contain doc strings, but the doc strings are more so for documentation purposes. And but in like, so they're kind of I guess you would say technically optional when it comes to standard Python coding. In the context of agentic coding, particularly within the Strands framework, this is the doc string actually informs the large language model to know, like, okay, what is this thing actually doing? Like, how can I actually make use of the tool? And within Strands specifically, it doesn't actually expect like a specific formatting. You can format the doc string however you want. I like to make it clear with a basic description of what the tool is doing, the inputs of what you can give into the tool, and what you can expect the tool to return. There are other agentic frameworks out there, like small agents, for example, that actually do expect a very specific syntax for your doc string to look. So just be aware of that if you're going to use any other agentic frameworks. And again, part of the reason that I'm landing on Strands here is it's really easy to work with, in my opinion. Like the other ones aren't too bad either, but this one is probably the simplest and most straightforward to me. And then B, so Amazon Web Services, AWS, is I don't know if they created the Strands library or if they had some sort of like, because sometimes something will like begin inside of AWS and then get spun off outside of AWS. But regardless, if you look at any of their documentation for services like Bedrock Agent Core, for example, they use Strands within all those examples. And just for context, I do think I want to cover Bedrock Agent Core at some point, but definitely not today. We'll definitely get to it in a future stream. And then you might be noticing at the top here, for those of you who are eagle-eyed, that you'll notice up here that it says Travel Planner AI Agent. ignore that for now. I will get back to that at the end of the stream and what that means. We're not doing anything travel planner related today. All right, so we created the tools. So in the previous stream, we had created the tools. I did add a additional third tool. This is just a letter counting tool. So basically, like you pass on an input string, and you pass in the character that you want to find, or like how much the character that you want to count the number of occurrences of, and then this little bit of code will do that just fine. So and part of the reason for that is because again, because large language models are next word predictors, and the way do I want to get too deep into this? Basically, like the way that like it's not necessarily next word, it's actually next token predictors. And I did a previous stream. It's been a while ago now where we actually created our own tokenizer using a concept called byte pair encoding, BPE for short. And so because byte pair encoding like chunks down the chunk like the token size in a certain way, it's hard for the large language model to gauge like how many letters are in something because a token may not be representative of a letter. In fact, a token could be as long as 5 characters even. It just kind of depends on the tokenization method that you're using, and then also the data that you're training the tokenizer on. Training is a strong word because it is, well, I'm going too far now, but anyway, so we set up our tools, we set up our agents here. So again, we tested out 3 different agents. We had our no tools agent. So this is just a bare bones agent where, this is actually not really even an agent. This is, we are making use of the Strands agentic framework here, but it is just basically just using the large language model itself for anything. Our second tool was an agent where we actually did pass in our custom tools here. And then our third tool, our third agent variant was basically the same as the second one, except we added a system prompt because you know me and I love to just be silly with the jar jarring stuff. And then at the bottom here, we got our invocation here stuff. So again, so we basically just covered what is an agent and what are tools and how do you use the tools within the agentic framework. What I want to cover today is, if you read the description for today's stream, is 2 other additional elements that are important when it comes to building agents and things that you have to be mindful of. And today is largely going to be more academic in the sense that we will be doing some coding, but I'm not going to go deep on the coding element necessarily today on I'll get into it here. It'll make sense in a little bit, but we're going to keep things more basic in terms of coding. And so this is actually the very first time that I actually created a PowerPoint. Well, not PowerPoint technically, an Apple keynote for today. And you'll see why here in a second. In fact, let's go ahead and jump into it. So the 2 elements that I want to talk about today in the context of AI agents is our memory. And when I mean memory, I mean like a literal memory in the way that you think about it. I'm not talking about like RAM, like how you think about memory in terms of computer. I'm talking about how does the agent recall its experiences to be able to leverage those past experiences to inform to kind of inform the behavior of the future thing that you're trying to build. And then the other thing that I want to touch on is observability. So what is observability? It is this idea that so if you don't have observability set up, an agent is a little bit of a black box. A black box in the sense that again, an agent we give the agent the tools that it needs to do to complete its job, but we are not telling it to take this tool, or use this tool, then this tool, then this tool. Agents are all about what the kind of like the term inclines there. It's about agency. How are we giving the large language model the autonomy to do what it needs to do? Now, the thing with that, though, is that if you don't set up observability, then it is a bit of a black box in terms of what you can or can't do. What you can actually know about what the agent did versus what you did. So for example, you could have 2 different, you could ask the large language model to complete a task 2 different times back to back. No change in the code at all. And it may converge on the answer the same way both times, but if you don't have the observability set up, then what could happen is that under the hood, maybe the first time you sent that task through, it invoked 1 tool and that was it, and it got to completion. And then on the second pass, it invoked 2 different tools, and maybe it invoked a tool 3 different times. And it's important to know that sort of thing because we would look at those two interactions and say, okay, they both got to the same place at the end of the day, but one took a far more inefficient path. The one that took the tool, like iterated over the tools multiple times, took a very inefficient path there. And that's not good in terms of tokens. It's not good, or token cost. It's not good in terms of latency. And so you want to have that observability set up so that way you can go back in the future and review what the agent did in various interactions to be able to better tune the performance of your system. And so we're not necessarily going to show today like how you can leverage the observability, but we are going to show how you capture it. So the ironic part about today's stream is we're actually going to spend more time conceptually talking about memory and less time talking about observability conceptually, but a lot more time coding observability and not as much time coding memory. And the reason for that is it's kind of a technical thing. It's just kind of, in my opinion, it's a little bit challenging to get the observability set up correctly. And like even today, the way we're going to demonstrate it, I'm not super satisfied with. I still have a little bit of learning to do myself there. But anyway, so let's get back to memory because I want to talk about this more using visuals. So this is actually the very first time, again, that I've created a keynote for this, and you'll see why. So this is the keynote that I created to represent agentic memory. I'm going to move my face to the top left here. Okay, so I don't like the way that looks. I might move it back. All right, so what you see here is we got the 5 horizontal rectangles, and then within each rectangle, you can see these darker rectangles, dark gray rectangles that represent each of the steps. So what is this representing here? So what this is basically representing is, so our gray rectangles, our light gray rectangles, represent each agentic session. And let's assume here that we are working with an agent that we're always asking it the same task, and we're always giving it the same tools. So that dark gray would be each tool that was invoked by the agent. And so you can see here, again, this is the totally fake example, that I guess we can also assume that the agent does converge on a final answer that we would expect every single time. But you can see across all these 5 different interactions here that we have inconsistent numbers of calls. And so maybe we got step 1, step 2, step 3, then step 4, and then we got this one that's got 5 steps. We got one down here with 2 steps, and then my face is in the way, but the bottom one there has 4 steps. And so there's a number of different ways you could think about memory, and there's not like an industry standard definition of what memory is. And so I'm going to cover the way that like how the general internet thinks about memory, but just be aware that this could be a little bit of a naive understanding. In fact, I do want to call out, a couple weeks ago, I actually did repost a post from a friend that I work with. His name's Kevin. And Kevin is actually doing some really, really fascinating work with a professor at one of the universities in town and trying to understand memory better. And so he's got a whole GitHub repo out there. If you follow me on LinkedIn, again, I reposted his post a couple weeks ago. His approach to memory with this professor is really fascinating and goes beyond what we're going to talk about today. So, but again, so this is kind of representing the picture here. So let's talk about the different kinds of memory sense. So the very first memory we're going to have is our working memory, our short-term memory. And so this is basically going to be always here. And this is even present in most instances where we're not even building an agent per se, but let's say you wanted to build a chatbot. Because again, remember, when we call up to the large language model, we are passing in a point in time sort of instance. So if I ask it, or if I tell it, I should say, remember my favorite color is blue, or something like that. And if I don't pass that text back in, then it's not like there's the model's magically remembering that I just said that. So if I were to actually not be mindful of memory here, or the working memory, then it would, if I asked the question, what did I say my favorite color was, it would say, you've not told me any sort of favorite color, blah, 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 something like that. And so what I'm trying to highlight here with the blue outline that I've added to this slide here is that with each respective session here, you're going to have it's going to have its own working memory, if you will, that will remember, okay, I took this step, then I took this step, then I took this step, then I took this step. So that is probably the most basic form of memory. And basically with all agents, you'll always want to have some sort of memory element like this. And sometimes they come pre-baked in, like a lot of the time they do come in pre-baked in and automatic. But we'll demonstrate this specifically with Strands later on in the stream. We'll code this up for ourselves. Okay, so that is working memory. Yeah, all right, so moving on to semantic memory. Yeah, so for the folks making comments about the audio, that was my fault at the very beginning. Again, I had my microphone not set up properly, so it's not anything you all did. It's something I did. Anyway, so moving on to step 2, we have or memory type number 2. We have our semantic memory. So imagine that we have all these interactions. So like me personally, I personally use ChatGPT the most often as my daily driver large language model, if you will. And so the one thing about ChatGPT, if you're familiar with that, is it will remember key facts about you over time. So we would refer to that as our semantic memory. So for example, if I'm asking it, all the time, how do I make this recipe or how do I make that recipe, then it's going to store within its semantic memory that I'm a chef. And then it'll probably remember that, and the useful part about that is if I ask something else going in the future, like if it's something more general, then it could recall that semantic memory to remember, okay, this person is a chef, so maybe I should couch whatever my answer is as a chef. Now, before we go any further, it's important to recognize that with all these different memory types that we're going to cover today, it is not imperative that your agent has all these different kinds of memory types. In fact, there are some times where it might not even make sense to do that. So I'm actually going to do a future stream on the various levels of AI agency, but like, because we touched a little bit on this in the previous stream, but basically when it comes to AI agency, you can have, it's a spectrum where you can have a lot of autonomy and a lot of agency. You just give it basically tell the large language model to have the ball, if you will, and it will basically try to do whatever you want it to do. But in the most narrow sense of agency is a basic router. So like, let's say I wanted the agent to basically take incoming requests and then send them down one path or send them down the other path. In the case of a router as an agent, because it's so basic, you may not need something like semantic memory here. And so I've highlighted this particular section here with this dotted blue box all around to kind of encapsulate the idea of like, okay, when I think about semantic memory here, I'm really talking about every single collection of all these different sessions here. I guess that is one thing I did kind of hiccup on there is these light gray boxes, each of these individual horizontal lines, we would refer to each of these as a session. And that's going to become important later because whenever we use the Strands framework to code some of these things, it will refer to the nomenclature of what we're trying to do in terms of like setting one of these things up as a session. So, and then we have the steps within the session. Now, there's not really I tried looking this up earlier. I didn't see like a good term that they were using to call each of the individual steps an agent takes as like some sort of special term. But like generally speaking, like these larger gray boxes, they are generally referred to as sessions. So that is semantic memory. Now let's move on to episodic memory. So you can see here now that the color around each of these boxes has changed, and it's basically trying to figure out what is the general experience of what the agent did in the previous sessions. Generally speaking, we'll talk about a different kind of memory in the next slide, but I am encapsulating with each of these various colors here that we're trying to get a holistic sense of what happened across this. So you could almost kind of think of it like a little bit of a summary, if you will. And there are different ways to code kind of episodic memory, but yeah. So again, here, let me move my face out of the way because not that way, that way. There we go. More room. So then you can see, if we want to have the agent kind of follow suit on to get a general sense of like what happened within each session, then we can refer back to the episodic memory. And then finally, we have our procedural memory. So what I did with the color coding here is basically each different color within these steps would kind of represent a tool. So green would be one tool, blue would be one tool, orange would be another tool, etc. And then you might see that I've got the dotted line around that center box there. So the center box here, well, I'm getting ahead of myself. So what procedural memory is we're trying to figure out, we were talking again before where, like, let's say you give a task to an agent with the exact same amount of tools, and then one agent called only one tool and got to the answer. Another agent had to call 3 tools and still got to the answer. That latter one would be wasteful. So, like, assuming that all of these got to the final answer, we would actually say that this one was most optimal for whatever reason. Now, I recognize that maybe this was not a great example given that we have these 2 down here, and you might be wondering, well, wouldn't less steps be more optimal? Maybe. So forgive me for the example here. But what I do want to highlight is something that I did intentionally, where almost all of these begin with step 1 as blue, using the blue tool. And then we have a number of these using step 2 from the orange tool. And what procedural memory is trying to do is looking across all these different these sessions to figure out, okay, what is actually the most optimal path here for a given task? And then that way we can use that information to, again, kind of help to re-engineer our solution to where it is always trying to land on this path here. We could do things like prompt engineering or more of a direct automation. So instead of, so we talked a little bit about in the previous stream where I would actually recommend automation. So automation being like a set ordered number of steps over agency. And so you may discover over time that, we started with an effort that was an agent. And then as we looked over the procedural memory, it actually made a lot more sense to do something that was more automated. Now, that's not particularly mandatory. We could also do things like prompt engineering to kind of help to land on what we would want to do with like this center box here. Okay, so I hope that makes sense. I'm just like mentally frazzled right now, and I can tell I just am stumbling all over my words today. I'm gonna blame that on the pre-Thanksgiving thinking about turkey, or thinking about like how I want to watch the new Stranger Things later. So, all right, that brings to the end my little keynote there. Thank you. All right, so let's actually get back into the code. So again, what we're going to code here today is we are going to add in memory, and I want to add in the observability. So again, the observability is basically piping out the interactions from our agent and then placing them into like a file or something that we could later review and make use of for the purpose of, procedural memory or other things like that. Okay, so we are actually going to spend more time on the observability piece because it's a little bit challenging to get going. And this is going to look a little bit different for different agentic frameworks. I guess the one thing to be mindful of, though, is a lot of the agentic frameworks are using OpenTelemetry specifically for as like the underlying backbone, if you will. Strands included. It is also using OpenTelemetry. And so I'm not an OpenTelemetry expert. Strands does attempt to make it easy. So basically what OpenTelemetry does is, like, let's say you have like an API that is basically manifesting, or like you have a server out there that is manifesting as an API with your agent code in there. OpenTelemetry, or OTel for short, as it's known, is basically, it comes along as sort of a sidecar, if you will. And then as we are generating our traces, so the trace would be like the sets. So if I come back to like this visual here, we'll just use this visual. So our trace would be a full representation of we took this step, we took this step, we took this step, and we took this step. And then might include more additional metadata. Could also note like the specific model that was used, etc. So typically speaking, when you set up OTel, you set up like this sidecar to pipe it into like a database or something. Today, I'm just going to have it write out to a local JSON-L file. If you're not familiar with a JSON-L file, it's basically just a JSON file, a different kind of JSON file. It's the L stands for line, so it's a JSON lines file. Okay, so let's go ahead and get the telemetry set up. So the very first thing that I want to do is, so we're just going to write it out to a file here in our source directory. So I am going to add just a thing that says this is my trace file. So I'm going to call my trace file agent traces dot, JSON-L. All right, so that part's done. Now, because we are making use of OpenTelemetry here, or Strands' implementation of OpenTelemetry, by default, when we start up the script going forward, when we have this telemetry stuff set up, it's going to be trying to reach out to that database or whatever for the traces. And again, we don't necessarily want it to do that, so we want to disable the OTel export and just have it pipe out to our file. So what I'm actually going to do here is I'm going to create a simple function. I'm going to call it OTel disabled, so that way whenever we can actually pass in a flag for whenever we start up this script, that would prevent the OTel from trying to reach out to anywhere, since, again, we're just going to write to a file. So I'm going to say OTel disabled, OTel disabled, and then it's going to produce a Boolean value, and then I'm just going to say return os.getEnv disable OTel export dot strip dot lower in. Why is the strip dot lower? What? Oh, that's because I forgot that. I'm going to disable. Where's my GitHub Copilot settings? That's going to drive me nuts. I'm going to pause the. Just FYI, this is something I kind of learned last week. Let me move my face out of the way for y'all. So down here in the bottom right-hand corner, if you do use GitHub Copilots, like sometimes the autocompletes are really helpful, sometimes they're not. You can actually snooze it. Like there's this button here, so I just clicked it a bunch of times so you can see that it is now snoozed for the next 45 minutes. So, all right, so now we won't have the that all popping up right now since I know what code I'm writing. So I'm going to say 1 true. Yes. Now, I'm going to be completely honest. I don't really know what this code is doing. Like, I know that it's disabling the OTel export. Again, this kind of goes above my head when it comes to OTel. I need to learn this a little bit better. But so this is just disabling that OTel from trying to reach out to like some sort of external source. So let's go ahead and set up a function that's going to handle the configuration, the tracing configuration for us. I'm going to say configure tracing. We're going to pass in our log path. It's going to be a path. I think I need to import, something else up here. So I'm going to say from path lib import path. Is that right? Yes. And then while we're up here, we do need to go ahead and add in Strands as a version of telemetry. So that is from Strands dot telemetry import Strands telemetry. Okay, so now let's go back to this function that I was starting to write. So we are going to do that, and okay. Now we're going to say instantiating the Strands telemetry object. So simply put, we are going to take this thing that we just, object, and we're going to make use of that here. So we're going to call this telemetry equals Strands telemetry. Okay. Now we're going to set our log handle, setting the log handle. So log handle equals log path dot open a encoding equals UTF-8. Okay. Now we're going to set up how we would actually export these logs appropriately. So we're going to say setting how to export the telemetry traces. We're going to say telemetry dot setup console exporter. And then we got to pass in a couple parameters. So we're going to say our out path is going to be that log handle that we set up above. Then we're going to say that our formatter, and we're going to use a simple lambda function here, not to be confused with an AWS lambda function. This is a Python lambda, span.to JSON plus. So basically this is, we're piping this thing out as JSON, and then we want to, if I can type right, add a new line. Oops. Add a new line. All right, there we go. All right, so now we need to do a thing for the OTel. So, I'm sorry, disabling the OTel. So if, yeah. Well, actually, so like this thing actually here is for if we were actually piping things into some sort of, like a telemetry thing. Oh, spanned. That's why I was wondering why that yellow squiggle was there. I meant to type span. So like this piece is actually not going to be used for today's stream because again, we're not connecting to any sort of formal OTel sidecar kind of thing. We're just piping out things out to the JSON file. So we're going to say if OTel disabled print remote OLTP export disabled via disable OTel export. We're just printing out, basically just printing out a line here that says we're only writing the JSON file. Only writing spans to JSON L only. Oops, that's redundant. Only and only twice. Now spans actually is a specific term, but I do not recall specifically how OTel thinks of strands. I'm quickly learning that I probably need to get more clear on how OpenTelemetry works in general. So I'm going to say else try telemetry dot setup OTel OLTP exporter. So this would set up our OLTP exporter. So OLTP, I don't remember what that stands for, but that's basically how we connect to like structured databases. Again, we're not doing that in this context, so this code is kind of neither here nor there. I still want to demonstrate it though for robustness sake. So in case you do actually want to take this code and you want to make use of it yourself, and you do have like an OTel thing that you have set up that you can actually pipe stuff to, this code will still work. But this code is actually not going to be functional for today's purposes. So exception as e print except why is this not try except oh gosh, I cannot type today. All right, there we go. I was wondering why that didn't automatically indent or highlight correctly. Print f failed to configure OTel exporter or OLTP exporter reason, and we're just going to pass in the reason here as an F. This is F string formatting. Okay, cool. And then finally, we are going to return telemetry and the log handle. Okay, so that is setting up the telemetry for us. Now let's actually go down here. So at the bottom of the script here, I basically like when the script is invoked, there actually is no like if name then main kind of thing set up here. But I actually do want to set this up now for this purpose. So let's go ahead and get that set up appropriately down here. So I'm going to say, I'm actually going to create a function also. I'm going to say def main. So this is going to be the main function that gets invoked. All right, so and we'll come back and get this other code from down here, and we'll bring it back up into this main. In fact, for now, I'm just going to put return none. I'm going to put if name equals main. main. Okay. So everything after this cursor here, we're going to end up moving back up into the main function here. So, okay, so when this main function is invoked, the very first thing that we need to do is we need to set up the telemetry. And so we're going to use that custom function that we created above. So, and again, recall here that we are already instantiating our agents. I'm going to do something a little bit fancy here just to for the purpose of like actually like invoking these example scripts. So I'm going to say setting up the telemetry. Telemetry and log handle equals configure tracing trace file. So we're passing in our log path and we're getting back the log handle. Now the only thing that we're actually not going to be making use of this object. That's why it's got the underscore in front of it. That's kind of just a Python typical thing where like if you're like, because we have no way of actually, I guess I could have set this up in such a way. Like, I'm not actually sure what you can use this telemetry thing for, but we're not going to use this one. We're only going to be using the log handle. So let's go ahead and create a dictionary that we can basically we want to do an iteration over each of our agents here. So we're going to say setting up an agents dictionary. So I'm going to say agents equals. All right. So no tools agent, that's going to be our no tools agent. Then we're going to have our tools agent, and that's going to be our tools agent. And if you're having a hard time following along, I will go back. Like I hope this will make sense once we actually invoke this script here, and then I'll do a quick recap once we finish writing the code, just to kind of tie everything back together. All right, so then our jar banks agent is going to be our jar agent, of course. Okay. Now I'm going to set up my prompts here. So I'm going to get my setting simple prompts for different scenarios. All right. So I'm going to say simple prompt equals what is the capital of Illinois. So to call this our control prompt, because recall that we don't actually have any sort of specific agentic tool that would do this. I just kind of want to demonstrate it as like this. Here's how the agent would still handle it, even if it didn't need to invoke any sort of tool at all. Our second tool is going to be our date time one. I'm actually not. So in the previous stream, you might recall that we do have a calculator function in here, but it took so gosh darn long for the model to like actually produce a response on the calculation that I'm going to ignore that for this stream. Like we're not even going to fuss around with that, and that's why I added our new one. All right, so our date time prompt is going to be what is the current date and time. And then, so I'm going to add in a string here. So recall that our third tool here is our character counter tool. So what we actually need to do is we need to create a sample like sentence and a sample like character that we want to look for in addition to the prompt. So I'm actually going to say, I'm going to call this count sentence. So this is going to be like our the sentence that we want to count the number of characters in. So we're going to say Strands is fun to work with. And we're going to say which letter. None of these are very frequent. We're going to say the letter S. So count character. We're going to say we want to count the letter S. How many occurrences of the letter S there are. And okay, so where's that prompt? What did I call this prompt again? Just looking back at my notes here below. So I'm going to say counting prompt equals, I'm going to do a little bit of f-string formatting here. How many times does the letter, so we're going to pass in our count character, so that is going to be how many times the letter S. I guess I don't even know why I did it this way. Like I could have just hard coded this all. Like I don't know why I'm passing it in variables like this. But anyway, so how many times does the letter S appear in the following sentence? And then we're gonna again All right, and then within these double quotes here, I'm gonna put our count sentence. So we want to count how many times we're going to do that. And then Okay, I think that covers that. Sorry, just reviewing my notes here. All right, so we set up our prompts. Now, the one thing I want to do, because recall, we do want to address memory, but today we are only going to address the working memory. And so the way that the working memory works within the Strands framework is basically you just need to pass in a session ID, a unique session ID. And so that way, each time you use that same session ID, Strands knows, okay, we are still within the context of the same session. So we need to refer back to the same session. So what I'm actually going to do here is I'm going to create another prompt here. I'm going to say summarization prompt. So we're going to have this last test case basically say, okay, what did I just produce? Like, tell me everything that I just did. So I'm going to say summarization prompt equals, please summarize everything that we have discussed so far. All right. Now, again, if we did not have the memory set up correctly, if we passed in this prompt and invoked the model, it would basically say, I don't know what you're talking about. We haven't talked about anything at all. So let's go ahead and iterate through. All right, so we need to set up like our various scenarios that we're going to go through. I'm going to say defining the scenarios for testing different prompts. So we basically have 4 scenarios here. So we have 4 scenarios here. So we have the simple prompt, we have the date time prompt, we have the counting prompt, we have the summarization prompt. So I'm gonna create a dictionary here. That way we can just simply iterate through each of these pieces. So I'm gonna say scenarios equals list. We're gonna give it a label of this first one to be the system prompt, or I'm sorry, the simple prompt. Didn't mean to say system prompt there. And then our prompt is going to be the simple prompt. Okay. Next scenario, label, date, time prompt. And again, our prompt for this one is going to be, as you can guess, the date time prompt. Okay. Next up, we are going to have our letter counting prompt. And it's not necessary that we're doing what we're doing here. This is just kind of more of a simple thing to, instead of like, I didn't like the way that this was all written out down here. This is kind of messy. So by setting it up this way, it's going to make our code a little bit more clean and hopefully easier to read. We're going to call this our counting prompt. And then finally, we have a label. We have our summarization prompt. And then the prompt for this one is going to be summarization prompt. Okay, so we've defined all of our scenarios here. We actually don't need this anymore. That was just a placeholder. All right, in fact, I'm going to go ahead and delete all this now because we don't really need any of this here now. Oh my gosh. Come on, let me highlight just... All right, let's not try to do that in one fell swoop again. Let's just do that. Okay, there we go. All right. Cleaned up that. All right, so let's iterate over each of these scenarios, by agent. So we're gonna we're first gonna go through the no tools agent. Then we're gonna go through the tools agent, and then we are going to go through the jar jar agent. So we're gonna say for name agent in agents dot items. So we're just doing a simple for loop here, grabbing the name of the agent, or so this and then this. So we're going to say, so this is actually where we need to set up a unique session ID. And so it is not necessarily proprietary to have like a very specific session ID. So Python does have this built-in Python library called UUID. I can't remember what UUID stands for. I think it's something universal ID, basically like that. So we're going to scroll all the way back up to the top, and we're going to import UUID. So import UUID. Okay. Now let's go ahead and set up the session. Instantiating the session ID. All right, so session ID. Sorry, I got to scroll down on my notes again. All right, so session ID, this is going to be a string. String equals string UUID.UUID 4. All right, so that's setting up a session ID. Okay, so now let's iterate through each of our scenarios. Iterating over each of the scenarios. For robustness sake, let me go ahead and add a comment. Iterating over each of our respective agents. Okay, that's good. All right, so iterating over each of the scenarios. So I'm going to say for scenario in scenarios. Forgot the colon there. There we go. So we're going to do first do a print of the session ID. So we're going to say print session ID for we're going to give the name of the agent. And so then we're also going to put in the session ID. Again, just some simple f-string formatting. Now we actually need to go ahead and call the agent with each of our, well, do I want to do, no, I guess I'm okay with that. Hold on, let me think about this. I don't think I'm thinking about this appropriately. Okay, I did not want to put this one in here because that's going to mess things up. So I'm going to re-add that at the end by itself. All right, so iterating over the sessions for session ID. Yes, so I don't know if I did the. Sorry, like the code is correct. I'm just not sure I like the way that I have the printing going out here. So I'm going to say I'm actually just going to get rid of this. Print starting. Where is the scenario label? Scenario. I forgot to put the F there. All right, scenario. Oh my gosh, I cannot type today. All right, why is this not highlighting? All right, there we go. All right, scenario label with the name agent. All right, so again, recall the name is just the name that we're working through. All right, and then we actually need to get the response. So we're going to say response equals. So this is where we pass in. So we're going to pass in our So again, we're iterating through here. So our agent is going to be whatever our agent is, and then we're going to pass in the prompt. So scenario is going to be prompt. So we're grabbing the value of prompt here. So again, so for this first one, our label here is going to be simple prompt, and then our prompt here is going to be the prompt itself. Now here comes the memory element. Watch this closely because you're gonna, if you blink, you'll miss it. Again, this is what I was talking about when I said the session. Actually, coding for the memory and strands for like the short-term piece is actually really easy. Session ID equals session ID. All right, that's it. That's really it. Basically, all you got to do is pass in the session ID, and boom, Strands is going to handle that telemetry on the back end. All right, so we're okay. So I'm going to print out the output. Print response. And then finally, because I didn't want to do this as part of this, because I didn't want to mess with the session ID, I guess it would have been okay to do. Yeah, I guess it would have been okay to do this here. All right, let's re-add this back. Label, summarization, prompt, summarization prompt. Okay. And so, okay, so we're actually gonna wrap this all, well, no, we'll go ahead and do that last. So, all right, so finally, after all this code has run, we are going to say log handle dot close. So again, this is helping with our telemetry. And then print f trace log written to trace file. All right, and that is all of our code. So let's go ahead and recap, because I am apparently just, my mind is all over the place today, and I am not thinking straight. So what did we add here? We added, we are going to write everything out to this trace file of this agent trace. We set up a couple of functions here. So this configure tracing function, this is setting up the telemetry. Recall that the telemetry automatically is using OpenTelemetry under the hood, therefore it is looking for some sort of OLTP server to write to. We are not writing an OLTP server, we are writing to a local file, so therefore we had to create this OTel disabled function, and that's what that is up at the top here. Then we basically refactored our examples. We set up the setting. This is just my personal preference. Setting up the telemetry, setting up the agents that we want to work through, setting up our different scenarios, and then actually having like a list that we can iterate over. And then finally actually going through and doing everything that we need to do as part of this. So let's go ahead. I'm going to say, I actually do want to put a print statement here. Print. Working with the agent, the blank agent, name agent. So that would be like the, the nose tools agent or the Jarger agent, etc. Session ID is session ID. All right. So now we're ready to go ahead and run this. All right. So again, recall here, clear. So in order to actually run this, so we're going to say, so this is a little bit confusing because typically speaking, disable, all right, so, oh wait, I'm not referring to the right one. So because I'm using the live stream script today, live stream. Most of the time, whenever you invoke a file like this, like a Python file, you usually pass in parameter flags, and we could have set it up that way, but we actually set it up this way. So we're basically saying we want to disable the OTel transport, and let's go ahead and run this. So let's go ahead and see once we run this what we need. Oh, I did not, because I'm working out of a virtual environment. I got to activate my virtual environment. That is activated. All right, cd src. Now let's try that. Disable. All right, so now it's going to, all right, has no path, log handle has no path open. All right, let me figure out what I did wrong here. Log path not open. Did I might have called that that might have been a goofy typo on my part. Let me check my notes here again. Okay. Here, let me close that down so I can get more to read. So log path is path. I'm actually going to not have it called a path. I just want to see what it does here if I do it this way. I did a little, again, I'm kind of refactoring my script here on the fly because I didn't really like it the way that I did it the first time. So let me see if this works. Has no path. Okay, so apparently I do need to set this as a path. All right, so I'm gonna re-add this back, and I'm gonna call this trace file. Oh, son of a gun. All right, hold on just a second here. I messed up something. src. Uh-oh. You can't see it, but like my computer is kind of freezing on my bottom screen a little bit here, but we'll get this worked out in a second. All right, so we're actually going to call this path file dot resolve dot parent, and then we're going to say slash agent traces .jsonl, because basically what this is doing is like it assumes that like if you want to run this script multiple times, then it's not going to recreate this agent traces file again. It's just going to keep adding to that file. Now currently it does not exist, but yeah, so I'm actually going to come down here as well then in our main function. I removed something before, but this was probably in error, or this was an error. Ooh, where did I put this at? All right, so it's actually in this, right in this configure tracing thing here. So we're going to say log path dot parent dot mkdir parents equals true, exist okay equals true. What this is basically doing is saying, okay, if we don't already have this file here and we don't have the parent directories for this file, then go ahead and create them. If they exist, it's already fine. All right, so that should have hopefully cleared up our issues. Let's go ahead and try to run this again. There we go. All right, so we are starting off with our first item here. So you can see here it's already starting to go through these things. I should have put some print line statements. So you can see here the first question, what is the capital of Illinois? I guess the answer is Springfield correctly. It noted that today's date is this, but that is not necessarily what we want. You can see here that the language model does not have access to the current time. And again, that is to be expected because these models are trained at a snapshot in time. It actually concerns me that the model knows what date it is, and that is because the only reason that concerns me is because that's indicating to me that behind the API, with OpenAI specifically, they've got some sort of system prompt behind there, and I didn't think that was the case at all, but they apparently do have some sort of system prompt that is being filtered through. So now we already went through that session, or that first agent, so it's already now going through the tools agent. You can see that with the get current date and time that it did invoke this tool correctly to get the current date. So today is November 26th. My local time is 2:54 p.m. It's actually 2:55 p.m. now. And then you can see that down here, I really should have put some better print statements down here. But you can see here with the summarization that because we did pass in that session ID, and let me see if I can find the session ID. So this is that I'm highlighting here. That would represent the UUID session ID that we are instantiating. So you can see just like it's a big long string of random characters and numbers. And that, all right, so it went through all this. So now let's go down here and look at the jar jar agent. So the jar jar agent starts at this point. So the very first thing it did was it went through this first prompt of trying to figure out what is the capital of Illinois, and of course it is doing this in the jar jar format. I am kicking myself for not putting in better print statements. So it did note that the starting date time prompt. All right, so it did know that the date time was correct because it invoked the tool as appropriate. Now you can see that in this last scenario here, the letter counting scenario, is that it actually did not leverage the tool. And that, again, as we highlighted in the previous stream, agents are inconsistent to work with, especially if you are approaching them naively and you're not approaching them in a correct way. Sometimes it will invoke your tools, sometimes it won't. All right, so we have, that basically covers the full JSON. Now you can see here off in our navigation that we have a new file here, our agent traces JSON-L file. And if we take a look at that, let me go ahead and collapse this down, move this a little bit over, move my face out of the way, bottom right. This is our telemetry. So you can see this represents everything that we had that was piped out whenever we were going along here. And so it's got a lot of different pieces of information that Strands specifically has kind of by default. So you can see here for like this very first scenario, so this would be like the no tools agent whenever we're asking it what is the capital of Illinois, that we had 110 input tokens, we had 204 output tokens for a total of 314. And then the time to first token was 26741. I think that might be milliseconds. I'm not quite sure what that is. You can see that I have a thing in here that notes that we are making use of the GPT-5 nano model. Again, it's kind of metadata. And then when we look at the events here, you can see that, so the way that Strands kind of works is a little bit, it can be a little bit confusing in the sense that like you see events here. This is not actually like the observability necessarily. We actually have to come down to this thing that's called like the execute event loop cycle. And then it's confusing to read, but all the information that we'd ever want to need is in here. So if we keep on scrolling down here and we look at the execution cycle, so if we come down to events, you can see that we are passing in what is the capital of Illinois. And then when we keep on scrolling down, we will eventually get to the point where it notes that that we have our choice was, our output was Springfield, and then that the reason that we finished was just an end turn. And so let's actually scroll down to the bottom to kind of show like a more complex one, or not complex one, but like one that's got more information in it. So you can see that it's outputting a lot here. And again, this all goes back to this idea of like procedural memory. We can start to make use of these traces that we output to say, okay, I'm seeing a commonality when we start to invoke these things, and so we can harden that somehow. Do we want to harden it with automation? Do we want to refine our system prompt somehow to get the agent to behave similarly over time? That's what this observability piece is really helpful for. So if I come down, keep on scrolling, so our very last one is going to be our jar jar summarization prompt. And so you can see here, let me find it, like where is the top level one? So, all right, so what is the capital Illinois? You could see that we are this would all represent, again, because we are using one session ID, all the events of the different session IDs. So the very first thing that happens, we ask what the prompt is. We get an assistant message back here. Next one, what is the current date and time? Our next thing here is we are invoking the tools agent, we are invoking the tools appropriately. And you can see here that it is noting each time what we are actually doing here. So this is the tool result. You can see that it output the time only, so then we pass that back into the model. Now, the one thing that Strands does not do by default that I kind of wish that it did do is it doesn't actually tell me the reasoning logic. I'm sure that there's something actually under hood that actually says, okay, I recognize that the current date and time is this. I need to reformat this in the output tone of Jar Jar Binks. You'll notice that that is not captured as part of the telemetry here, not by default. I'm going to guess that there probably is a way to set that up. And then as we keep on scrolling down, so I say, please summarize everything. And then you can see that the generative AI's choice is to just summarize everything with this prompt here. So that is observability in a nutshell. And there are other tools out there. So like part of the reason that I'm not super concerned with trying to figure out my own version of telemetry is I mentioned at the top of the stream that I'm more so working in AWS with Bedrock Agent Core these days. And the nice thing about Bedrock Agent Core, just at a super high level, is basically we could still use all of this. And but we don't have to set up like this whole OLTP thing. That's kind of like a one of those things that are a given for you if you use Bedrock Agent Core. And so then in Bedrock Agent Core, what it does is it pipes everything into CloudWatch, and there's actually a new interface within CloudWatch that makes use of X-Ray behind the scenes, and then some other new thing that actually presents all your traces appropriately in CloudWatch. So that is out of scope for the stream for sure. But actually, that kind of brings us to the end of today's stream. So again, we only took a very cursory glance at an abstract level of what memory is, and then the way that we implemented it here was very, very basic. Again, it's just this line right here. I just realized I never actually printed out that response. I think it was just printing because that's how the Strands framework works. But yeah, the way that you would actually leverage memory is not like this in other contexts. Like for work, so we demonstrated working memory with a session ID. Semantic memory, the capture and the recall might be very different for something like this. So the capture might be that you actually don't capture it like on the fly per se. What you might actually do is you might use like the traces here to say, okay, what are the semantic memories that I need to grab from this whole trace stack here? And then what you might actually do is you might pipe those all into like a vector database for a RAG kind of thing. So that way, we could even add a step in here or some sort of mechanism to our agent that says, okay, by the way, I've got the semantic layer here with all these facts about everybody, leverage them how you need to see fit. So then with a vector database, you could do the whole RAG kind of idea where it says, okay, here's my input prompt. Look into my memory to see what sort of semantic facts do I know that would be relevant to that prompt. Again, there are a number of different ways that you could do this, and then I guess the only thing that I want to call out is that the agentic frameworks that we're working with, like Strands, for example, they don't necessarily have direct mechanisms for that. Like you actually do, like there's not like a semantic memory module built directly into Strands, and that's kind of intentional on their part because I think they probably recognize that people are going to code memory a little bit differently. And again, talking about Bedrock Agent Core actually does have a built-in short-term memory and a built-in long-term memory. They don't delineate between like what is procedural memory and whatnot. And then you might have like with procedural memory, for example, the capture and the recall is going to look again a little bit different here. So the way that I would approach procedural memory. How would I approach procedural memory? I would definitely want to make use of the trace stack here. So for like these traces here, my hunch is that there's probably like some sort of, for lack of a better word, like an optimization algorithm that would be able to comb through all of these and say, okay, we recognize that, the most optimal path forward is step 1, step 2, step 3. I'm not, that is something that goes beyond my head right now. I'm going to have to look into that, like how I would actually do that. And then I would want to leverage the output results from that to either do, again, a direct automation instead of having an agent, or still having an agent, but having more strict parameters around it. So I guess the one thing I do want to close out today's stream with is we've been working a lot with strands throughout this whole process, but of course there are other agentic frameworks out there. And a lot of them do more or less the same thing. The one that is different is LangGraph. And LangGraph, I was not planning to show this today, so I'm going to have to pull this up on the fly. LangGraph actually takes the approach of coding up agents. I don't know if this is even the right URL. Yeah, that's not. I'm going to just have to Google it. LangGraph. LangGraph takes the approach of coding things in as a graph, or more specifically a DAG being a directed acyclic graph. Is there a good visual on here? Again, I wasn't planning to show this today, so I don't know if I'm going to be able to find a visual. Directed acyclic graph. This is probably not a great version of one, but I guess this works here. But you can see here what a directed acyclic graph is basically saying. So imagine this in the agent context. So the way the agent context would work is, so you'd start at node A here. So just again, for context, if you're not familiar with DAGs here, again, DAG stands for directed acyclic graph. Now that name sounds fancy, but keep in mind here, so directed, meaning that we're going we are going a specific direction. Acyclic, we're not going through a cycle, it's going to end at a certain point, and it's a graph. So we call these circles here as nodes, and we would refer to these lines in between the nodes as edges. So you can see here, when we start at node A here, then we can go to either node B, C, or B, D, or C. If we choose to go to node B, then we only go to node D. If we are at node C, we can only go to node D or E, and etc. Or I guess from A, we could jump straight to E. But I guess the thing I want to highlight here is that LangGraph is the only agentic framework that I know that you can actually specifically code something like this. And part of the reason I've been so focused on Strands is because, and admittedly, part of the reason why I've been a little bit struggling with the code a little bit in terms of the telemetry is I had AI help me write this to an extent. Like I wrote a good chunk of it myself, but I did not really write like all the OTel piece myself. Now I did review it, of course, because I wanted to make sure I understood it. But like, so I'm going to go ahead and actually create a new file here. I'm going to call it LangGraph agent.py, just to kind of show you, like, when you learn one and you code one, you can basically just tell like an AI coding tool to go ahead and basically do the same thing elsewise. So I'm going to say in here, all right, please replicate the exact same functionality as so the way that we do it here in GitHub Copilot is we use the pound sign. So we're going to use please replicate the exact same functionality as that file, except using the LangGraph framework. Please be aware that I am working in a virtual environment at the root of my repo under them. And the reason I'm doing that is because if I don't do that, then sometimes it tries to like create its own virtual environment. So I'm being explicit here. So now I'm not sure like if this is gonna work right out of the box the very first try. We'll give it a shot here, but my point here though is like when you conceptually understand one agent framework and you code one agent framework by hand, assuming you do it by hand, then you just use the AI coding tool to have it do it in any other framework for you. So let's see how well it does here. No. There is no need to create a workspace. Green initiate after this question. Okay, so there's a question in the YouTube chat here. I had this question about LangGraph when designing a chatbot. How does LangGraph scale if there's like 100 people with comes concurrent? How does the chatbot with LangGraph know how? So basically, so if you have like 100 people, like you basically assume that there's like 100 different threads there. So and in that sense, it's almost like it's one different thread. So when you code up the actual the agent itself, it's going to go through that graph that you create there. So it's going to go to node 1, and then it's going to determine what is the next appropriate node I need to go to. Maybe it's node B. So now I need to go to node B. And then when you actually get to like node B, then it would be aware that, okay, I only have within node B the context to work within like these different sort of tools. Basically what I'm trying to say here is it kind of more or less does not matter if there's like 100 concurrent tools, because it's almost like it's creating 100 different threads, if that makes any sense. But a good question there. All right, so not sure how to help with that. I didn't even pay attention to that. Well, I already have the file structure set up. Determining user intent. My intent is for you to not redo what I've already done. No, I just want to add it to the virtual environment. No, please just add the code to LangGraph. And again, I already have a virtual environment. I don't usually have issues like this. Sometimes I have seen this issue before, but usually like when I say use my virtual environment, it knows to use my virtual environment. And if this doesn't work out, I'm not going to fuss around with it too much. I just wanted to highlight that, if you want to use a different framework, you can use a different framework. It's just a lot easier these days to use AI coding tools. And the AI coding tools, to be completely honest, as helpful as they are, they've almost made preparing for these streams not as fun, because part of the fun part for me was just trying to figure out what these things were trying to do. And now that, because the other nice thing about GitHub Copilot specifically is you can actually go, like, if I have like this documentation here, or like if I actually dug into the documentation here, I could actually just pop out this URL and say make use of this documentation. It'll actually reach out to the internet and grab the documentation. Makes everything just way too easy. Like that, what's the fun in being so easy? Okay, so it looks like it's trying to do it this time. Okay, we'll see how this works out. In fact, I'm going to go ahead and delete this agent traces file. Delete. That way we can go ahead and have it created anew. Why did it not write to the file? Usually it just writes right in place, so let's go ahead and... All right, I guess this button will do it. Okay, I think I need to probably install some stuff. So uv add langchain open AI langgraph. That's just a guess off the top of my head. I hope those are correct. What is React? Oh, okay, so you could see, so it's setting up the LTP. It's got our tools set. The only thing about LangGraph is that the syntax for it's a little bit strange. Now in this particular case, it's not that complex because we're not setting up like specialized nodes and edges. So I think this should work though. So let's go ahead and try it out just out of curiosity. So disable OTel export. And we're gonna say LangGraph agent.py. I don't expect this to work on the first try. Yeah. Okay. Function must have a docstring if a description is not provided. I'm going to say fix. All right, hopefully we'll fix that. Can you make these edits directly to LangGraph? I don't know why it's doing this. Usually it just does directly do like, yeah, this is driving me nuts. Why is it not making, usually it'll just make it like right in place here. I don't know why it's doing this. It's kind of frustrating. All right, hopefully this button will do it. Okay, now I think that may have helped. Looks like it may have done something better there. So let's try that again. All right, another issue. All right, I basically what I could keep doing is just, keep trying to fix this. Fix. Actually, you know what? I'm just going to start a new session. Fix. Okay. Keep. I'm not really sure what it did there. Got no. All right, I give up on this for now. I could keep fussing around with this, but like I think what the better path would have been to do is to actually find the documentation and have it referenced directly. But for the most part, I do know enough LangGraph to know that this is probably pretty close. There's probably just some little goofy thing in there, but I feel like wrapping up for today. All right, so that covers that. Oh, I guess that was the one thing I did want to talk about. So we mentioned very, very early on that this travel planner AI agent. So actually what I intend on doing as part of future streams is just to help ground our knowledge and go way more deep on things like memory and telemetry, etc. We're going to do a multi-part stream going forward where we're actually going to build a travel planner, or a vacation planner, I should say. So like, let's say I'm wanting to go to Italy. You can imagine that we could take a number of different approaches, but basically the approach that I want to take is I'm going to have my holistic travel planning agent, and then I'm going to have a bunch of sub agents. So I'm going to have maybe one sub agent that's like booking airlines, another sub agent that's looking for best places to eat, etc. Organize all those together with A2A. So that is not a topic that we've not covered. So I think I am going to do a dedicated stream to A2A. So I got again, a lot of content in the work right now for AI agents. So we mentioned that we're going to do one on the levels of agency. We're going to do one on A2A, and then we're going to do a multi-part stream on building our whole travel agent kind of project. So that is to come, but not today. Today, I am going to go take a nap. And then I'm going to watch Stranger Things at 7 p.m. Central. Because I'm looking forward to that. So that wraps up everything for today. Hope you all have a good day, and hope you all have a happy Thanksgiving. Thanks for watching.